All right, so let's chat a little bit about this. Okay, so on this first problem, okay, trying to figure out whether or not it is a quadratic. If you find the first difference, so remember that's subtracting between here and here, that would give me 3. If I subtract between here and here, that would give me 6. Next one would give me 10. Next one would be 15. The difference between these would be 3, 4, and then 5. So is that second difference the same? No. Okay. On the next one, I'd find the first difference. And then the second difference. If the second difference is the same, then that one is a quadratic. On the next one, the second difference is the same. So this one is a quadratic. And this last one, the first difference is the same. What is that called? A linear. When the third difference is the same, third difference won't happen, but exponential, remember, is a ratio that can multiply all the way down. Yeah, we'll talk more about exponential later. If you can recognize linear and quadratic, then you're good. Okay. On problem 3, or slide 3, we're using this function. So the ball landed 4 seconds away after it was thrown. Is that a true statement? Yeah. Okay. Okay. Think about this really quick. Read this again. This represents height. And then this represents the amount of seconds that was on the ground, or I'm sorry, in the air. So is this really representing that it landed 4 seconds after it was? This is a trick question. It does. Why? Because the height is 0, so that would be at the ground. Okay. Because half of y'all are paying attention. I could say something crazy. All right. So when x is 2, what's our y? On 128. Is that a true statement? Okay. Why do you know that? Because this one is also 0, 128, so the height's 128. This line right here is called the axis of symmetry, which means that that parabola is folded in half. So whatever happens on this side of the parabola also happens on this side of the parabola. Okay, so that one is also true. On the last one, it says Tay's window is 144 feet off the ground. Is that a true statement? No. What was the height of the window? Okay. All right. Slide 4. Drag the points to create a parabola that is concave down. That means it's facing downwards and has an x-intercept at 3. So it's just got to cross the x-axis at 3. You probably could have gotten a couple different answers for this one, but this is a possible answer. On slide 5, it says drag the points to create a parabola that has a y-intercept at 0, 6, and a line of symmetry at x equals -4. X equals -4, that line of symmetry means that that middle has to run at x equals -4. Then we were wanting a y-intercept at 0, 6. So we can kind of move it in or out. It might take a little bit of time to finesse, but there is a potential answer. You might have gotten something different. That's okay as long as you meet those 2 requirements. On the next one, s equals 4. Okay, so right here we see that there's a box, and then we have 2 added onto the side. Here's another box, added 2 onto the side. There's another box, added 2 onto the side. But notice how the number keeps increasing. So what is this box going to look like? It's going to have 4 sides. I'm sorry, it's going to have 4 on one side, 4 on the other. And then it's going to have like the little 2 sticking off. This equation would look something like this. The reason why we know it's a quadratic is because it creates a square, not a rectangle. Creates a square, not a rectangle. on slide 7, is this a quadratic, a linear, or none, or exponential? Quadratic. That's what we've been talking about. The reason why we know is because it creates a square. You can see that if we did 2 times 2, that would give us 4. Notice how there's 4 boxes. If we did 3 times 3, that would give us 9 boxes. Okay, so if you see a square in one of those little pattern things, that's probably going to be a quadratic. Okay, this one always trips people up. Which one has the larger maximum? Well, the maximum for this guy is 25. For this one, we have to find the first difference, and then we have to find the second difference. So the first difference was 12 and 9, and then the second difference was 3. So that means that the next one is going to also be a second difference of 3. So what's the difference between? Okay, cool. And then that means that 21 plus 6 gives me, okay, which is more than this guy's maximum. So D of X already wins. Okay, and so for your like explanation, you can just kind of talk through the first and second difference. On the last slide, okay, which one has an x-intercept at 10? Okay, you would have to continue this. And remember, this has a axis of symmetry at x equals 5. So the same thing that happened over here is going to happen on this other side. So is that going to have an x-intercept at 10? Yes. Okay. What about this one? Well, we would have to continue this. So would that have an x-intercept at 10? Well, if we continue down, no. Because look at where the vertex is. Vertex would lie somewhere in here, which means if we doubled that, that would be 11. Okay, between 5 and 6, it would probably be about 5.5. Okay, so it would just be f of x. Okay, so the goal is to write an equation of the parabolas that'll break through the target. Okay, looking at this one, did this person accomplish it? Mm-mm. Okay, so how would we change this in order for it to hit that? Okay, so change the 2 to 3. And then let's try it. So did I make it through? Yeah. Okay. Looking at the next slide, here's another challenge. Okay, so if we try it as is, it goes through 2. But how do we make it go through this one? Well, what if we flipped it upside down? Well, how do we flip something? You subtract or you make something negative. So let's try it. Ta-da! Okay, so I put negative x plus 2 times x minus 2. Go ahead and try slide number 3. Go ahead and try slide number 3. How do we write, like right now, this is what it looks like. So it goes through there. Okay, how do we get this to flip upside down? Except, good talk. So she's saying, make it negative. Ta-da! Okay, questions on that? All right, on slide 4, collaborate with Carlos. Write another equation to finish this. Go ahead and take a moment, see if you can finish this one. All right. Okay, on this one, this is what he got. Okay, so he got the first part pretty good. And then that second, come on. And then that second one, it didn't go through here. How can we make it go through this point? Well, what if we took the same equation, and we just changed the number out front. What if we made it 2? So we make it through? Yeah, what did that do to the function? That made it skinnier, right? Okay, so if we have a number that's out front, that's going to make it a little bit more narrow. That's going to make it skinnier, okay? Go ahead and take a look at slide number 5. Go ahead and take a look at slide number 5 and see if you can break those targets using the 3 things in there. Okay, so this is one of the answers that somebody put, okay? Is there any way to modify this last one to make it hit this little? Okay, so it's going to be 1/2 or 0.5. And watch it. So that first one, second one, and then that third one. So 1/2 makes it wider. Okay, so 2 makes it skinny. Anything less than 1 makes it wider. Okay. How do we get this x minus 1 and x minus 4? Where does that come from? What are these called? The x-intercepts. So notice how there's a crossing at 1 and 4. So we're going to switch the sign and then put an x in front of it. Okay, go ahead and take a look at slide number 6. See if you can describe that. Okay, so some of y'all said that this would get wider because it was 1/2. That is correct. It would cross at the x-axis at -3 and 2. Good. All right, go ahead and skip to slide 8, 9, and 10. On 8, 9, and 10, I'm going to give you about 10 minutes to try to get through these challenges, and then we're going to check our work. Kind of thing. Okay, so let's talk through this first one. If I'm crossing at 1, 3, what is that, 5, and -1, here we go. -1, -3, -5, and 1, 3, 5. If I'm trying to write this as an equation, remember I changed the sign and write it out. So I could do x plus 5 times x minus 5. And then the next one I could do x plus 1 times x minus 1. And then the next one I could do x minus 3 times x plus 3. And let's see if that got it. Ta-da! Now, you could have come up with something else as long as it breaks all of the little things. Okay? Go ahead and try slide 9 and 10. Okay? Using the whole x-intercepts and then the direction. So on this one, I'm gonna look at some bodies. All right, on this one went through. Okay, so you would have to have a positive version and then a negative version. Again, yours might look a little different as long as you broke all the tiles, that's okay. Okay. All right, on the next one, so here's challenge 3. Challenge 3, you could have like a couple different versions. Okay, so Jason, did you get it? Okay, so Jason almost has it. We need one more this way, though. We need one more. Well, actually, 2 more. What you got going on here? What is this? Okay, so you put 2. Hey, what if you did this? What if you took this out? Let's see what happens. That went through there. How can I make it go through the 2 dots? I need to make it wider, right? So what if I make it 1/2? Let's see what happens. That's close. We need to make it even wider. So what if we make it 1/4? Boom. So there's 1. But now we got to cross through here. What if we make this that? Okay, so we definitely need to make it a little bit wider. So it's gonna be like, let's do -1/2. Close. What about -1/4? Somebody needs to turn their music down, please. Okay, so this kind of creates this whole like guess and check. Obviously this would be a little bit easier because you'll have Desmos, that kind of thing. Okay, but you can play with this and move it around until you get your final answer. One answer that you could have gotten on this one was this, maybe. Okay. All right. Go ahead and skip to slide 13 and tell me the strategy that you use in order to solve that. Yeah.
Slide 9, response 2. How did you do the last one? I thought it at the bottom.
Let's see what this. You could use this. So you would have to do one that's upside down, so a negative version. And this is not the only answer. So. Uh-oh. All right, so some of y'all are talking about how you would find the x-intercepts, and then you would graph from there. You can graph and then kind of do like a guess and check. That's okay sometimes. So go ahead and take a moment. On slide 14, you're going to organize these cards. You're putting the equation with a graph. Okay. I'm going to put it up here whether or not it's correct. So if you see a blue check mark, it's correct. If you see orange, it's not correct. Answers. Check your answers. So, good. It should be, the negative is going to be the one that's facing down. The 1/2 is going to be the wider one. And then this one, you have to make sure that you pay attention to the x-intercept. So it should be 3 and 5. And in the equation, it's going to be -3 and -5. Okay. So negative out front means facing downwards. 1/2 means wide. And then -3, you got to flip the sign of what's on the graph. So since it crosses at 3 and 5, you're switching the sign and then putting an X in front of it. On your mastery check, you'll be given some graph. And they're going to ask you what type of function this is. Is this linear, quadratic, or exponential? Okay, so it's a quadratic because it's got this U shape, right? It's a parabola. Yes. Okay. All right. Now, the next question that you're going to have on there is, does it have a max or min? Does this one have a maximum or a minimum? Maximum. A maximum or a minimum is the same thing as a vertex. Okay. Where is this located? At -2, 9, right? Good. Okay. Now, the next question that you're going to get is the axis of symmetry. The axis of symmetry is this line that runs all the way down through here. This is the x value of the vertex. So that is x equals -2. Okay. Are there any questions on that so far? Okay. The next question you're going to get is, what is the x-intercept? Looking at this, it crosses at -5 and 1. So you would write -5, 0, 1, 0. The next question is, what is the y-intercept? So what is the y-intercept? 0, 5. Are there any questions so far? The next question that you're going to have is domain and range. Domain is going to be -infinity to +infinity. Your range is going to vary depending on the problem that you have. So down here at the bottom, how low does it go? Well, it goes down to -infinity. How high does it go? Well, it stops at 9. Okay. Any questions on that? Domain is -infinity to +infinity. The last question is in behavior. This is as if you were standing right here and you look to see where the graph actually ends up. Well, the graph is pointing downwards, right? So that means that it's going to negative infinity on both sides. Another way to say that is that this is decreasing. Okay,